Oh,
Okay,
CJ,
I
you
am
jokester.
recording now. So today we're going to do, by the AP standard, it's 8.7. But the rest of Unit 8 is basically integrating to find volume. There's Ty.
Oh my.
Hey, Ty.
Just show
On
up
time as
whenever.
always.
Okay.
Can we get another argument today? That was the greatest thing ever.
Okay, mute all. All right, great. Okay. The rest of Unit 8 is finding volume using integrating, basically. So in order to kind of figure out all the different types, I'm splitting up the classes into different cross sections. You might have done this last year or not remembered, or maybe you didn't do it. I don't know. But today we're gonna do.
Definitely didn't do it.
Oh, okay, that makes sense. So today we're gonna do square and rectangle cross sections. I'm gonna do my best to draw this on the whiteboard. I practiced on my own paper, and it looks kind of cool. So I'm gonna try to do like a 3D drawing on this 2D whiteboard on my iPad. So a lot of things working against me today, but we're gonna get there. Once today's lesson is done, I will email you or actually you already have the assignment, which is the notes that I emailed to you yesterday. So if you reference those, that's good for today, so you can follow along. So there's 7 problems on the PDF I sent you yesterday. Just make sure you can refer to those, just because there's a lot of words that I don't want to write on the whiteboard app. My plan is to get through 4, and then you guys finish the remainder of them for your assignment. So whatever we get through today, hopefully the first 4, you'll have 5, 6, and 7 to turn into me by Friday at 3:15 p.m. Blackbot is working again. So even though on that PDF it says to email me your answers, please submit them on Blackbot. There's an assignment Dropbox on Blackbot, so it's easier for me to have them in one spot. Friday's not technically like a school day for you guys, really. I mean, sort of, but you don't have classes. But it's still going to be due Friday by 3:15. But you can turn it in early, so you don't have to worry about stuff on Friday. If you have questions, my office hours are today and tomorrow at 2 to 2:30, and then Friday at 9 a.m. Your English and math teachers have 9 a.m. on Friday. Okay, let's get started with the first one here. All right, I need to bring up the PDF on my computer actually to see what it says. But this one is about a circle centered at the origin. Well, we're going to center it at the origin with a radius of 1. 1 second here. Oops. Okay, so this one says the base of a solid S is a circle with a radius of 1. Cool. So it's a solid, so it's 3D stuff that we're doing right now. And if you imagine like any type of solid, like if you take like my water bottle, for example, right? It's like a cylindrical solid. So if we took cross sections of it going across, they'd be circles. Just like slicing through, what's the 2D shape that you see, right? So those would be circles. We're going to work on cross sections that are squares and rectangles today. So this one says for this solid, the cross sections or the slices are perpendicular to the x-axis and they're squares. So I'm going to do my best to draw this. The way that I found is best to draw is like kind of sideways. So let me try this. So here's our x and our y axes. Try it one more time. So that's the x and that's the y. And I'm drawing them kind of sideways so I'm able to show like a height of this solid. And so if I go out 1 unit in each direction, I can draw the circle. So there it is. Okay, I unmuted you because I just feel lonely when I can't hear anything. Okay.
Now I can talk trash.
Perfect. Okay, so now we have
And hopefully
cross
Mr. Busman
sections
gets on.
perpendicular to the x-axis. So if we look, our x-axis, you know, obviously where it is, but we want to draw squares that are perpendicular to it. So basically the base of these squares, the squares are going to be coming up towards us. The squares are going to be coming off of the screen. So that is what I'm going to try to draw. So we basically want, so I'll draw one square. There's the base of the square. And then it's a slice of this. So it comes up and goes out like that. I wonder if I can make this smaller.
So this is an underestimate.
So it's basically adding a height to it. So I'm going to draw another square that's smaller. So there's another one. Then I'll draw another one like the first one. And we can keep drawing these squares so that they're coming up towards us. So what I can do also is share with you this really good Khan Academy video. He draws them pretty well, and I think they're easier to see. But essentially what we have is a bunch of these squares, and there's like an infinite number of them basically, and they sort of make this 3D shape going over they make this like 3D shape here. I know it's like hard to see, and I'm trying to do my best here with it, but basically it's creating this 3-dimensional shape where the base of it is that circle, and it like puffs up almost like a croissant or something, and all the cross sections are squares. So in order to find the volume of this, which is our ultimate goal, the volume is going to be
Cubed.
the integral, or the sum, right, of all of these cross sections of squares. Because the squares are essentially what makes up the volume of this object. So we have to figure out what is our area. Okay, and we're traveling from left to right on the x-axis. And so since this square has a radius of 1, it starts over here on the x-axis at -1, and it goes to +1. So those are our limits of integration. We have to figure out what this is. The A just stands for area of each individual square, and it's going to be in terms of x, which is why I wrote it as A of x. So we have to figure out the area of each individual square, and that's probably the hardest part. So what we're going to do is write out the formula of, or the equation rather, sorry, of that circle. This guy right here. So this is a circle, it's centered at the origin, and it has a radius of 1. Who remembers how we can write the equation of a circle?
Great, guys.
Don't all shout it out at once.
Pi r squared. I don't know.
That's the area of a circle. In order to write the equation of a circle,
Like y minus,
radius,
or y like h minus k thing.
Yeah.
yeah, so it's technically this. Gabriel said the correct one for this in particular. Gabriel, I'll get to that in just a second. I'm going to write out the general formula for the equation of a circle.
Wow, you
It's
want
x minus h quantity squared plus y minus k quantity squared equals the radius squared, where h and k are your center. So our center is 0, 0. So in this case, it's just going to be x squared plus y squared, and then our radius is 1. So it's just x squared plus y squared equals 1. So that's the general formula for this particular circle. And since we want this in terms of x, we want everything in terms of x, we need to solve for this. We need to solve for y, so we can get y equals something. So I'm going to erase a little bit here and rewrite it so I have some room. So that's the equation of our circle. And to solve it for y, what we're going to do is subtract x squared and then take the square root. So we've solved it for y because we want to get things in terms of x here. We're going left to right on here, traveling from here to here. Okay, now we have to think about how do we find the area of each square? Well, how do we find the area of a square just in general?
Length times width.
Okay, and it's a square, so what do you know about the length and the width?
They're
They're
gonna
the
be the
same.
same.
They're the same, right? So it's basically just the side length of the square squared,
Squared.
okay, or times itself, right? And you can think about it as based on side length times width, side length squared, whatever. So because it's a square, let's take a look at one of these squares. I'll highlight one in particular and make it blue. This entire length right here of this square, we could say that that length is 2 times the y value. Think about that. From here to here is the y value because it's going up to the y value of the circle. Then it doubles because it also is going beneath the x-axis. So this length right here is 2 times the y value. Well, the y value is right here. So the area of our square, a of x, is its side length, which is 2 times the y value, which is this. And then it's that length squared because it's the area of a square. So I'll go through that one more time. We are looking for the area of each one of these cross sections. The cross section is a square, and in order to find the area of a square, we have to take its side length and square it. So its side length is 2 times its y value. The y value goes from the x-axis up to the circle. That length we determined was the square root of 1 minus x squared. It's double that because it goes the same length beneath the x-axis. So we take 2 times that length and then square it. So we can now plug in to find the volume of this entire solid. We are taking all of those infinite number of cross sections that travel from -1 to 1, and then we're plugging in a of x. Now, before I plug in a of x, I'm just going to write out what it actually is when we square it. So if we square this, we just square each part since it's being multiplied. So it's 4. Then we want to square this square root, which just removes the square root. So it's times 1 minus x squared. So that is what we're integrating. That's a of x just simplified. So we're integrating. Go ahead.
Would you distribute the 4 or just leave it out?
You can if you want. I'm not going to just for ease. I'm going to put the 4 out front of the integral. But yeah, you can. That's fine. Okay, sorry. I'm still getting used to this whiteboard, so I'm like running out of room more quickly than I thought I would. So I'm going to erase the blue. Is that okay?
Yes, so, Coach.
Okay, because I need to keep working going down.
Ale.
All right. That says dx right there. Whoops, just erased it. Just kidding.
You played.
Okay, so you can take this 4 out front just to make it easier, or like CJ said, you can distribute the 4 through and integrate it that way. It doesn't matter. You'll get the same answer if you do the math right. So I'm going to take 4 times the integral from -1 to 1 of 1 minus x squared. So we can just take that 4 out front, and then we can just integrate. So we have the 4, it's doing its own thing. Then we'll integrate here, so we'll be left with x minus 1/3 x cubed. And we want to do that from 1 to -1. or -1 to 1 rather. And then if we plug in 1, so the 4 stays way out front. We'll plug in 1 first, so we'll have 1 minus 1/3. This is like the easy part. And then we'll plug in -1, right? So -1, and then if I cube -1, it'll give me -1 times this minus 1/3 will end up being a plus 1/3 in there. Okay. So we'll have a 4 out front still. 1 minus 1/3 is 2/3. And then this right here is -2/3, but it's minus that. So it'll be plus another 2/3. So we essentially have 4 times 4/3, which is 16/3. All right, at the top of your notes, it says volume of a solid. And we'll write in what to put there, but I wanted to do this first example first so you could kind of see some of the notation that we used. So I'm gonna erase this beautiful drawing.
No.
I know.
Coach, you could teach AP art.
Wow. Thank you. I don't think I've ever taken one art class since like 8th grade. Okay, so volume of a solid. Is anyone taking AP art?
Me?
Gabriel, you are?
Yes, ma'am.
How's it going? How you doing that stuff online?
All we have to do is submit our artwork by the exam date. So really, I'm doing nothing right now.
Gotcha. Okay. Cool.
Yeah.
All right, let's write what to put for volume of a solid. In general, you want to have the volume is going to be the integral from A to B, which in this case, our A and our B was -1 to 1 because that was just the problem. But it's going to, goodness, I didn't mean to write that. I meant to write A to B. A to B. And then it's the area of your cross section. So this could either say A of X dx, or our volume could be going from A to B, A of Y dy. And that just depends which way our cross sections sit. That first problem, they sat perpendicular to the x-axis. So we used x and dx because it went from left to right. We're going to do some examples, I think number 3 and 4 are perpendicular to the y-axis, and they're going to be in terms of y. And then what is A of X and A of Y? A of X and A of Y is the area of one cross section. And today we're focusing on the cross sections that are squares and rectangles. So they're going to be the area formulas for a square or a rectangle. But we'll get into some where they're semicircles, circles, discs. I think that's it. Okay, how familiar is this?
Non-existent.
Partly.
Okay. Good to know. Okay. All right, let's take a look at number 2. If you want to put this into your calculator, the 2x minus x squared, you can, but we know that it's going to be a parabola that opens down. So in number 2, it says the base of a solid is the region in the first quadrant bounded by y equals 2x minus x squared and the x-axis. So we only care about that piece of the parabola, like the top curve of it in the first quadrant. And then again, we're gonna have the cross sections perpendicular to the x-axis, and they'll be squares. And then we need to find the volume. So we'll do this beautiful drawing again. If you want to put that in your calculator, go ahead to see what it looks like. So we only care about quadrant 1. And this is a parabola that hits the x-axis at 0 and 2. And then its vertex is at 1, 1. So it looks like this. And again, it obviously goes on infinitely downward, but we only care about it in the first quadrant. So that is that part of our parabola, 2x minus x squared. So I'll write that out. It's y. Okay. And then we need to draw in those cross sections. They're perpendicular to the x-axis and they're square. So I'm gonna draw those in red. So here's one of them. And it's coming off the screen towards us, so it's 3D. There's one. Here's another one. Here's another one. And so on. So there's an infinite number of them, and they make this 3D shape like coming out towards us. And it gets wider in the middle and then small at the ends. And so we need to find the area of each one of those cross sections, because in order to find the volume of the solid, because we're perpendicular to the x-axis, we're traveling from 0 to 2. And we need to find the area of each cross section square. Okay, ideas on what the side length of the square is?
1.
It's the height.
Oh.
Y value.
Yeah, it's the y value. Look at this square right here, this little guy. I mean, its height, or its side length, basically, because it's a square, is this distance right here from the x-axis up to the parabola. That's the y value at that point. So the y value is given to us right here. There's no need to resolve for y. This one's already y equals something in terms of x. So in order to find the area of each one of those squares, it's a square, so its side length is 2x minus x squared. Whoops, 2x. And then it's a square, so we have to square the side length. I keep forgetting to write things in. There we go.
It's okay.
Thank you.
Oh.
I'm making fish sticks.
Yummy.
What?
Sounds good.
Yelling at my dad.
Oh, that reminds me of that one South Park episode with Kanye West. Anyone ever see that one?
I didn't see that one.
Okay.
I don't watch
I'm
that.
watching, but not that one.
Where's Tony at? Oh, he's here.
I'm here.
What's up, Tony?
Hi, Tony.
Hello.
Okay, so that's the area of one of those squares. Again, because it's just the side length squared. I feel like I keep repeating myself. I just want to make sure that you guys are understanding this here.
Can you say it one more time?
Is that a real request? Or I can.
No, I'm just kidding.
Okay, all right. So now
But
we
just to
integrate.
make sure.
I mean, oh, okay. All right, so now we integrate, but I don't want to integrate that thing squared, so I'm just going to square it out, multiply it by itself, right? So if we take this and multiply it by itself, that'll allow the integration process to work.
4x.
I just combined like terms there. Okay. So that's actually not that hard to integrate, really. I mean, the calculus part is like the easy part, which it usually is. It's the algebra and like the prep work part that make this a little bit difficult, I think. So we want to integrate this from 0 to 2 with this guy. And I'll leave you guys to it here. This one gets a little crazy. So here's kind of the deal. I will let you know at the end which of those 3 that will be your assignment that you can use your calculator on. This is the setup work that I need to see. If you don't want to draw it out, that's fine. If you can just like see it without drawing it. But the setup that I do need to see, even if you can use your calculator, is finding the area of the cross section and then setting up your integral. At this point, I realize that this one was kind of a crazy one. If you want to do it by hand, you can. I like the algebra, it like calms me down. But if you want to just do it from here on your calculator, you can.
More
So if
power
you want
to
to get
you.
practice, yeah, you will end up with 16 over 15. I want to make sure we get to the other 2, so I kind of move a little bit quicker here. That's the answer. Just use your calculator from here. So again, calculator active problems, I do still need to see the setup. So this is considered setup. And so is this, like finding what the area of the cross section is. So that's the algebra setup that I need to see. The calculus is fine if you use your calculator for that part. All right. Okay, let's do number 3. Number 3 and I think 4 are y-axis ones. So we'll be in terms of y. Number 3 is definitely a calculator active problem, but we'll set it up.
Oh my.
I can just click new page. I don't have to erase it. That's so cool.
Wait, Coach, if we do the 4 in here, how many do we have for homework?
I know it takes a BC student to figure this out, but there's 7 problems total.
I didn't know the total. All right now.
Okay.
Thanks I even
You'll
looked
have
at that
3.
sheet.
You'll have 3. Oh, wow. Okay. Well, we've been referencing it all class, so I'm hoping that you have it. Okay,
Coach,
number 3.
I'm going to do the homework. April Fools.
I tried to pull an April Fool's on my husband today, and it didn't work.
Did you make an algebra joke?
No, I was like, Governor Northam made or extended the stay-at-home order until July. Can you believe it? He's like, ha ha ha, April Fools. I'm like, damn, I'm not good at lying. Did anybody get April Fooled or pull an April Fool's today?
Someone tried me at 1 o'clock in the morning. I was like, not happening, not today.
You were awake at 1 a.m.?
Coach, sleep is for the weak.
Oh,
I'm like a bat.
What?
Sleep is for the weak.
whew.
A
Okay.
cup of water on my system.
Funny, because you sleep during class, right?
Yeah, he
me?
said during the sleep is during the week, right? Not the weekends. That's what he meant.
I said
Okay.
sleep. Exactly.
Number 3.
Oh, I know.
We got the base of a solid, again in the first quadrant, bounded by y equals cosine and the axes. Okay. From 0 to pi over 2 on the x-axis. Then we have the cross sections are now rectangles, but they're perpendicular to the y. And the height is just 4 times the width. So I'm going to set this one up by drawing it.
Bro.
So we'll have our x and y axes.
Tie.
And then we want to go from 0.
We have 2 ties in this chat right now.
What?
Gabe.
Mm.
Straight up, straight up.
Oh.
Classic.
Okay. So what is the cosine at 0?
0.
Everyone together.
1.
1. Good job. Thank you, John.
Woohoo!
And then what's the cosine at pi over 2?
0.
All right. So basically it looks like part of a parabola, even though it's the trig function. Oops. A little more curved. Okay, great. So that is y equals cosine x.
What?
All right, then we're also bounded by the x and y axes. So we're essentially, it's this like quarter circle basically that we're doing. So now all of our, I didn't really draw this in the best spot because it needs to go tall too. Let me just do that again really quick, sorry.
Oh my.
Oh my goodness.
What
my
in
bad.
tarnation?
What in the hell?
Forgot it has to go tall because the height is tall here. All right.
Like tying Gabe's hair. Classic. Ty, keep your chin
Okay.
up all right now.
All right, it's up.
Okay, so let's draw these in blue. So now they're perpendicular to the y-axis. So here's one. And then the height of this, it's not a square, so it's very tall. It says the height is 4 times its width in the xy plane. So it's going to be coming off the page quite tall.
Yeah.
So there's one of those infinite rectangles there, infinite number of them.
Society
Here would be another one. What's up?
Society says, you know.
Mm-hmm.
No response.
Coach, don't you miss us in class?
Totes.
Something
All
like
right, that one went off the page because it's so big. And then this one here will be smaller. So again, I'm just drawing random rectangles. There is an infinite amount of them. And the biggest one would extend from 0 to pi over 2 as its base and go up very tall. Okay, so this is going to be a very tall figure and the cross sections are all rectangles. Now, if we see this, because we're perpendicular to the y-axis now, we need to be in terms of y. You guys can see that we're going down here all the way up to here. And so we're no longer in terms of x. So we have our function, but it's in terms of x. We need to get this function in terms of y to solve for x. How do we solve this? Y equals cosine x. How do we solve that for x?
Take the
Arc
inverse.
cosine.
Arc cosine, right? Or cosine inverse. So if we cosine inverse this, x is the cosine inverse of y. And that's what we're going to use. That is this length right here. See how the length or the base of each one of these rectangles is an x distance. It's going left to right. And the x distance is cosine inverse of y. That's this length right here. So our volume is going to be an integral in terms of y. What's our lowest y value? What's going to be our lower limit for y?
0.
0.
0. What's our
Yes!
upper limit?
1.
No.
Okay, good.
Yeah.
All right, then we need to figure out what a of y is. The area using the variable y. So let's figure that out. So that's the area of each one of those rectangles. So it's not a square anymore because the height is 4 times the base. Well, we just found that the base is this distance here, this length, which is its x value, which is cosine inverse of y. So area is base times height. The base is cosine inverse of y. And the height is 4 times that. So it's 4 times the cosine inverse of y. So this is 4, and then cosine inverse of y
Squared.
squared. Cool. So it does have to be written the squared on the outside because this already has like an exponent to it. It's kind of weird. But from this point, we can put it into our calculator and it can give us a nice answer. Make sure you're in radian mode, which you probably should be. I say that because my pre-calc is doing degrees. All right, so we're going from 0 to 1 of this. 4 cosine inverse of y. I think your calculator makes you put this in parentheses too when you enter it in. Squared dy.
How do you get the y on the calculator? Just doing it in terms of x?
Just got a phone call. Don't know what that was. Okay, so let's put this into our calculator. When you're using your calculator, it's still going to be the variable x, which we're used to. So we're obviously doing this using y. On our paper and in our hearts, it's in terms of y. But in our calculator, it needs to be with x, unless you want to change it. So go ahead and plug this in, math 9, and then do your thing. If you want to enter the function into y1 instead to make it easier, you can do that.
I think I got it.
Okay. All right, what did you end up getting?
4.566.
Good.
Gabe's probably trying to do it by hand right now. He looks so concentrated.
Man. Man.
Mad.
No problem.
PY, did you just say what I think you said?
I said Yachman.
Oh, I thought you said
All right,
Yachman.
this one is definitely harder to put into your calculator,
You know what I mean?
but you should end up with 4.566. So I'm going to show you how I entered it in. No, it's kind of hard to see, but so I went from 0 to 1, and then I just entered in, obviously we'd use x, but I use the insert to get the squared. So second delete key to get that insert and then put the squared in there. But it ends up being 4.566.
Oink.
If the squared was hard to get, you can always just enter it in as 4 cosine inverse times another cosine inverse. Like you don't need to use the squared. It will still work if you didn't do that.
Coach, 9
Okay,
minutes.
we're gonna do one more. Guys psyched? One more. All right.
Yeah,
Number,
hi.
number 4. Okay. Number 4 is that weird like
All right, now.
lightning, I don't know, whatever that is, shape. So number 4, R is the region and it's bounded by 2 graphs, x squared and 2x. And then again, we're going to be perpendicular to the y-axis. So I'm not going to draw this one because it's already drawn. So yes, I saved the best for last. I don't have to draw it. When we are trying to find basically the area in between those two, if you're doing stuff with respect to y, which we are, we need to take the right function minus the left function. So which function is more to the right in that problem?
The top one.
Run. What?
The top
X
one.
squared.
X squared. X squared is the arced function, right? And 2x is linear. So in order to find a of y here, we'll do that off to the side. I will draw this just a little bit just to show you.
Folding, coach.
I'm folding? What's that mean?
Oh gosh.
If you know, you know.
Okay. So this one's y equals x squared.
If you and I, you and I, you and I.
Okay. And this is y equals 2x. So the distance here and here, right? That's the base of those rectangles. I'm not going to draw the height of the rectangle. The height of the rectangle is, it's a square. So the height is just going to be the same as the base. But that's the base of that. But we're going from right minus left. We're perpendicular to the y-axis. So we need to get these in terms of y. We need to solve each one for x, because we're traveling from 0 up to 4 on our y-axis. So we need to solve y equals x squared for x. So we'll have that x is the square root of y. And then go ahead and solve this one for x. We'll get 1/2 y or y over 2, however you want to write it.
Wow.
So this is what one of those squares looks like there. Okay, now we're not going all the way to the y-axis. That's why we have to subtract. So in order to find the area of one of those squares, we need to figure out the base length, the side length of the square, which is taking the right function, square root of y, and subtracting the left function, y over 2. That's the length of this side of the square. So it's square root of y minus 1/2 y or y over 2. And then it's a square, so to find the area of it, we square it. We're doing that an infinite amount of times for all these infinite amounts of squares, traveling from where y is 0 up to where y is 4. And I got those two values just visually, but if you plug in 4 for each y, I'd get x is 2 and x is 2. That's where they intersect. This is the coordinate point 2, 4, which you could just get visually because it's already drawn. So what we are doing is we are integrating this from 0 to 4 because this one's in terms of y. So we need the limits as y values instead. So our volume goes from 0 to 4 of each of those cross-section areas. And you can put this one in your calculator just for sake of time here. When you put that in your calculator, you will end up with 0.533. I did this problem twice by hand and made 2 really dumb algebra errors throughout it.
It's okay,
So
that's
in
calculus.
case- Yeah, I was just like, what is going on? So anyway, that you can just use your calculator. So again, this is the setup that I need to see. I need to see you solving for things if you need to get them in terms of the other variable, the integral setup, okay, the area. This is called the setup. So for problems 5, 6, and 7, which is your assignment, do the setup. I need to see that work. But then the calculus part, once you have the integral set up, don't need to see it. You can just put it in your calculator and get practice with the calculator. That's fine. We've done this enough. I've seen that you guys can do this stuff. So
45-minute AP exam.
I know the length of this class today, basically.
Nope, this is longer.
Are they going
5
to charge
minutes
this?
longer.
Oh, okay. Are they going to charge the same amount for a 45-minute exam as
I
they
mean,
are
we
for a
already-
3-hour exam?
Probably.
We
I'm
already
looking at
paid.
Ty right
Almost
now.
the same amount of money.
Thinks I ain't gonna sue BCP for spending my money I didn't ask for.
Thinks I ain't suing College Board.
All right, guys.
Thinks I don't
Biggest
hate-
scam?
thinks I
You
don't hate
have
College
the
Board.
assignment. Upload it to Dropbox, just those 3 problems, please.
I'm going to email it to you.
If you have questions, office hours today and tomorrow at 2 to 2:30, Friday 9 to 9:50. Any questions for Peace?
No.
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 Wait, Coach, how do you
Hi,
do
guys. Do
Bye
what?
now.
Adios.
Bye.
Bye.
All right, now, Coach. Have a great day,
Alright.
you and I.
Me too. What's up, John? Did you have a question?
I was just joking, asking how do you
Oh.
do the whole thing.
Oh, I was like, wait, what? How do we do this? Okay. All right.
I don't know. I feel like I have a harder time paying attention for a 50-minute class period than I do just trying to figure it out for the 30 minutes it would have taken.